I might have just done the strangest calculation in my life. Hey guys, thanks for joining us in this FY6 classroom video, and I want to share with you a really weird calculation that I just did. If I could share this website that I was just looking up, this is an article from USA Today. This article was written somewhere around June 26, 2017. Anyway, it's talking about someone who was falling from a ride at Six Flags. They referenced this trauma anesthesia book. And whenever you look at the trauma anesthesia book, they say the median lethal distance for falls, or the LD50, is 4 stories or 48 feet, which is, somewhere around 15 meters, not exactly 15 meters. So that means that 50% of people who fall from 4 stories will die. So this led me to think, well, how fast are they falling when they fall 48 feet? So anyway, I did some calculations and I just wanted to share them with you really quick because I think they're kind of strange. So we know that 48 feet is equal to about 14.62 meters. So I'm looking for a final velocity. And I know when people are falling on Earth, their acceleration due to gravity is about negative 9.8 meters per second squared. And now I know that the distance that they have to fall is negative 14.62 meters. And I also know that if someone is falling, most likely you treat them like they're just dropped and their initial velocity is going to be 0 meters per second. So using this information, I can say, well, VF squared equals VI squared plus 2AD, just using one of my kinematic equations. And the initial velocity is 0, so I'm just going to cancel that out. So VF squared equals 2 times negative 9.8 times negative 14.62. So I can say
2 times 9.8 times negative 14.62 is equal to 286.552, and I need to square root both sides of that, so if I just swipe over, hit square root, I get the final velocity of
16.93 meters per second, not squared, just meters per second. So that's how fast you have to fall to have a 50% chance of dying. But I thought about this and I was like, what if we were to do this on other planets? What if we were to do these same calculations for other planets and see how high can you fall before you have a 50% chance of dying? Because other planets have different accelerations due to gravity. So what I did is I just created a little Google Sheets document to do the calculations for me because I don't want to do these calculations over and over again. So you can see here I already have the Earth tab filled out, or the Earth row, I should say. You can see the acceleration due to gravity on Earth, 9.8. The death fall speed is 16.93, and that converts to 37.9 miles per hour, which means that you fall for 14.62 meters or 48 feet, and you fall for a time of 1.73 seconds. And basically, I went ahead and plugged in all the calculations, but the main thing is we know that if you fall 16.93 meters per second, that's the speed that you're going to have a 50% chance of death, which is also 37.9 miles an hour. So for these two columns, these numbers are just going to stay the same. However, the acceleration due to gravity on the different planets does change, and I have those put in here for us to look at. So you can see Mercury 3.59 meters per second squared. So that's a good bit less than Earth. Venus is actually very similar to the acceleration due to gravity on Earth. Then we have Mars, which is 3.77 meters per second squared. This one might actually be the most important statistic to look at because we're looking at sending people to Mars. So maybe it's a good idea to know how far can a person fall before they die on the planet Mars. Maybe OSHA requirements might show up or something for that. Anyway, then we also have the moon, 1.62 meters per second. Jupiter, you see that one is very, very high, 25.95. So you accelerate very quickly on Jupiter. Saturn, 11.08, Uranus, either way you say that, it's wrong. 10.67 meters per second squared. Neptune, 14.07. Look at Pluto, 0.42. Barely any acceleration due to gravity. So we can use the same kinematic equation to figure out that deadly height for every single planet. So you could say VF squared equals VI squared plus 2AD, and then we just do a little bit of algebra to figure out the height. So initial velocity is still 0. We can just cancel that out. So we're left with VF squared equals 2AD. Divide both sides by 2A. And you have VF squared over 2A equals distance. And that's the equation that I used for this death fall height column right here. So here's basically the gist of what's going to happen. The higher the acceleration due to gravity, the lower the height you can survive a fall from. And inversely is true as well. The smaller the acceleration due to gravity, the higher the height is. So with those calculations, let's just go down the list. Mercury has a death fall height of 39.9 meters, which is equal to 131 feet. Good bit higher, and you're going to fall for an entire time of 4.72 seconds. And then let's check out Venus. So on Venus, you're going to fall 16.2 meters, which is a height of 53 feet, around 1.91 seconds to fall. Very similar to Earth. Let's check out Mars, probably the most important one to look at. You can fall a height of 38 meters on Mars before you hit that LD50 for height, which is 124.7 feet, and you're going to fall for 4.49 seconds. It's a long time. Let's check out the Moon. 88.5 meters. 290 feet, you're going to fall for 10.45 seconds before you hit that LD50 number for height. Jupiter, this one's probably going to be really small. Yeah, you can only survive a fall of 5.5 meters, which is 18.1 feet. That's less than 2 basketball goals. And you're only going to fall for 0.65 seconds. That's crazy. Let's take these next 3 right here and let's just reveal them. So all of them from 10 to 13 meters. 33 to 44 feet, you're going to fall for 1.2 to 1.59 seconds, somewhere in there for Saturn, Neptune, and Uranus. All of those numbers significantly less than Earth. And then finally on Pluto, well, how far can you fall before you have a 50% chance of death? 341 meters or 1,119.5 feet, and you're going to fall for 40.31 seconds before you have a 50% chance of death. Anyway, guys, I thought that was really interesting. I figured I'd share it with you. The link to this spreadsheet is down below. And make sure that you go ahead and subscribe and follow me so that you can get more weird, interesting calculations in physics like this. Thanks for watching.